Okay, let's see how to solve these questions on Miliequivalent, since we said it's one of the ways of expressing concentration of electrolytes in solution. So let's see how to run these calculations on Miliequivalent. Before you do this calculation on Miliequivalent, you must have it in mind about this formula. You must have these formulas in mind. Number one, that Miliequivalent is equal to milligram times valency all over molecular weight. Molecular weight. Yes. You can also have this formula in mind, Miliequivalent per mil. Once you say Miliequivalent per mil, this one will be milligram per what? Mil times valency all over molecular weight. Then, if you say Miliequivalent per liter, whatever you do to this you do it to milligram. Are you getting it? So this will be milligram per what? Liter times valency all over molecular weight. So these three formulas, you must have it into your fingertip. You must memorize it. You want to do well in these questions on Miliequivalence. Let's see. What is the concentration in milligram per mil? Which formula? We'll be talking about this now. Of a solution containing 2 milliequivalents of KCl per mil. Wow. And they gave you MW molecular weight to be 74.5. I will say I am looking for milligram per mil. This one. That means milliequivalent per mil, which is milliequivalent per mil. I will now say 2 equals to, I'm looking for milligram per mil times, what is the valency? Valency of potassium and valency of chlorine, they are 1. We are taking 1 because valency of potassium is +1. Are you getting it? And valency of chlorine is -1. We don't use negative sign there. So we just say their valency are the same. Just take 1. If their valencies are not the same, they are not going to be giving it to you here. They will use one of the cation of it or one of the anion of it and ask you about that. But because the valencies are 1, that is why they say potassium chloride. But if the valency of potassium is different from valency of chlorine, they are not going to give it to you because you'll be confused of which one you have to use, so to speak. And so 1 all over what? Molecular weight of potassium chloride is 4.5. So what is the value for your X, which is milligram per mil? You say X, which is equal to milligram per mil. S is equal to this times this. This times 1 is S. This times this is what? So 4.5 times it. That will be 149 milligram per mil. Remember, these three formulas, you must have it into your fingertips. Now, to answer question number 2, a solution contains 10 mg% potassium ion. Express this concentration in terms of milliequivalent per liter. You say, since they are asking me to get milliequivalent per liter, I will use this formula. Look at, I'm looking for this. Are you getting it? So I will be using this formula. Are you getting it? That means the milligram I am seeing here will be milligram per liter. But what does 10 milligram percent mean? It means 10 milligram in 100 mil, because percent means 100. So I will now say in 1000 mil, which is equal to 1 liter, so that it will be milligram per liter. In 1000 mil will be what? 1000 times 10 divided by 100. That will be giving 100 milligram. So that is 100 milligram per liter now. Are you getting it? So that means I have to get this in liter, which is 100 milligram per liter. So I will be saying the milliequivalent per liter I'm looking for is equal to 100 times. Now, because they are talking about potassium, they are specifying the cation. Valence of potassium is 1. I will say 1 all over molecular weight of potassium. Potassium is 39. Yes. Molecular weight for potassium is 39. I will say 39. So the answer will now be 100 divided by 39, and that will be giving you equals to 2.56 watts for milliequivalent per liter. Yes, and that is the answer for question number 2. Now to answer question number 3, how many milliequivalents of KCl are represented in a 15 ml dose of 10% KCl LEC? Now, they say 15 ml dose of this. What does 10% in pharmacy, what does it mean? When we are talking about concentration, percentage concentrations, this 10%, what does it mean? It means 10 gram in what? 100 ml. 10 gram in 100 ml. This one, we say in 100 because they are specified milligram already. But here, they did not specify whether it is milligram or anything. Once they did not specify whether it's milligram or gram or kilogram or whatsoever, it means that you now know that it has what? Intrinsic, like invisible what? Gram in it. Whenever you see 10% in percentage calculation, 10% means 10 gram in 100 ml. If you are talking about mil aspect. But let me let you understand something. If you have what we say 10%, maybe weight per weight, it means 10 gram in 100 gram. Because they say weight per weight. If you have 10% what? Weight per volume, it means what? 10 gram in 100 ml. Then if you have 10% what? Volume per volume, it means 10 gram in what? 10 ml in 100 ml. That is volume, that is, it will go by volume. 10 ml in 100 ml. Are you getting it? Now, but when they are talking about this one, they did not specify to us whether it is what? Volume per volume, weight per weight, weight per volume. They did not specify. But why did we say 10 gram in 100 ml? That is a question. The reason is because they say 15 ml dose. And again, we are what? Looking for milli equivalence of it. And in milli equivalence, we don't deal with mil per anything. We are dealing with milligram. Are you getting it? And so that is why we say that it's likely going to be 10 gram in 100 ml. So 10 gram in 100 ml is this. Are you getting it? Convert this to what? Milligram. What will it give you? 10 times 1000. That is 10,000 milligram is in what? 100 ml. That is not in milligram, in ml. But I'm looking for what? Milliequivalence only. Then I will say in 15 mils. In 15 mil, this one is in 100 mil standard. In 15 mil, what will it give you? I will say 15 times 10,000 divided by 100. That will give you 1,500 milligram. Now, as he has given you 1,500 milligram, I will use this formula because this formula is looking for milliequivalence only. So I will say I'm looking for milliequivalence equals to, this is what? 1,500 times what? This valency, this is KCl. The valency is 1. So we take 1 all over what? Molecular weight is what? 39. Is 74.5. Because the atomic mass of potassium is 39. And for chlorine is what? 35.5. Then their standard. Their standard. So this plus this will give you 74.5. So we say this divided by 74.5. 15 divided by 74.5. That will be giving 20.13 equal to 20.13 what? Milliequivalents. Remember that blood plasma contains 154 milliequivalents of cations and what? 154 milliequivalents of what? Anions. Don't forget that. And that is why we are discussing all these things, because they are used in a lot of formulations we have in infusions. Are you getting it? Syrup, suspension. We use all these units, milliequivalents, to do the formulation, so to speak. Okay. In question number 4, a solution contains 10 milligram percent. What do we mean by 10 milligram percent? It means 10 milligram in what? 100 ml, because percent means 100 of calcium ion. You see, the specified calcium ion means the valency is 2 now. Express this concentration in terms of milliequivalent per liter. It means I'm looking for this formula, this one. Now, if I'm going by that, milliequivalent per liter, this is 10 milligram per ml. I will say, let me convert it to what? To liter. That means 1000 ml, which is 1 liter. So 1000 ml will be what? 100 milligram, because this times is divided by this will give you 100. This times this divided by 100 will give you 100 milligram. And so I have gotten in milligram per liter, which is this. I will now say milliequivalent per liter will be equal to milligram per liter is 100 times valency is 1 all over. What is the what? Molecular weight of calcium, they say is 40. I write 40. 100 over 40 is what? 2.5 equals to 2.5 milliequivalent per what? Liter. Can you see it now? So that is answer to question number 4. Going to question number 5. They say a 20 ml solution of what? Sodium chloride contains 5.13 milligram. In this case, this 5.13 is inside 20 ml. Or we say 5.13 milligram is in 20 what? Ml. What is the concentration of the solution in terms of milliequivalent per ml? That means I'm using this formula, milliequivalent per ml. That means I have to get it in milligram per ml, ba? Then times valency all over molecular weight, ba? Okay. Now see what you do here. You say divide here by what? Okay. In 1 ml. In 1 ml, what will it give you? Divide here by 20. Divide here by 20. Why? You are dividing this by 20 so that you get it in milligram per what? Ml. You are dividing this by 20 so that when you divide this and this, you have 1 ml. And divide this and this, you have it in milligram. So 5.13 divided by 20, you have 0. What? 2565 milligram. Milligram in 1 ml. Because for you to get it in milliequivalent per ml, here must be milligram per what? Ml. That is the rule. So I've gotten it to be a milligram per ml. Next thing I will do is I will now say milliequivalent per ml is equal to 0.2565 times what is the valency of this? Valency of this is what? Is sodium is 23. This one is what? 35.5. That means it will give you 58.5. 58.5. So we say sodium is 23 plus 35.5. That is 58.5. So valency of sodium is 1. Valency of chlorine is 1. I'll say 1 all over what? 58.5. So I will be having 0.2565 divided by 58.5. That will be giving me what? 0.00 what? 4 what? 4 milliequivalent per what? Mil. Are you getting me the point? And so that is how to solve these questions on milliequivalence.